Welcome to day 2. Homework is package page 15 and 16. We'll look at some more arc length and area of a sector today and also look at radian measure of angles. So we've got a warm-up. See if you can use your notes from yesterday to set up your proportions and solve what they are looking for. So go ahead, pause the video now, do the warm-up, and a box will pop up for you to put in your answer. So start with our central angle of 22.5 over all the way around would be 360 degrees. Because we want to have theta over 360 equals, we're giving the area of the sector, so the area of our sector over the area of the whole circle, which is pi r squared. So the area of the sector they told us was pi over pi times r squared. R squared is what we're looking for. Notice you have a pi both top and bottom on the left, so those can divide out. So you really just have 22.5 over 360 equals 1 over r squared. If you didn't divide the pi out there, you could have just cross-multiplied right away and divided it out later. If we cross-multiply, we get 360 equals 22.5 r squared. We'll divide both sides by 22.5. And that would give us 16 equals r squared. We then take the square root of both sides, and our radius is just 4. If we look at our units are inches. So 4 inches would be our radius. If we move over to the homework, the first two we were finding the arc length, so we wanted the circumference down on the bottom right, so 2 pi times the radius, so 20 pi for the first one. Remember, it can be easier working with smaller numbers. Over on the left, I chose to reduce the 72 over 360 to 1/5. If you didn't do that, you could have just cross-multiplied. You'd end up with the same answer eventually. Notice these don't say to round, so we should be keeping them in terms of pi, and make sure you put units on them. So 4 pi centimeters and 8 pi inches. Each of these, we are finding the area of the sector. So on the bottom right, we should have pi times radius squared. Pi times 10 squared would give us 100 pi in the bottom right of that first one. Pi times 12 squared gives us 144 pi in the bottom right. Again, I like to reduce when you have just numbers on the left there. So you have 1/5 and then cross multiply. Or you could have just cross multiplied. You have your calculator. So like as we're doing this part here, just do the 100 divided by 5 and then leave the pi on. Notice our units are squared because we had areas. 20 pi squared centimeters, 20 pi centimeters squared, and 48 pi inches squared. In 3, we were looking for the central angle. We were given an arc length, so you needed 2 pi r in the bottom right for each of them. So like in the first one, the pi's divide out and 3/12 reduces to 1/4. So that's the way I like to do it. Again, could have just cross multiplied and worked through. You'd end up with the same answer eventually anyway. So you get 90 and then 135. And the last ones were given the arc length, so we need 2 pi r in the bottom right. And then we are eventually solving for r. So if you cross multiply, you could either have 15 halves or 7.5 for 4a, and then 6 feet for 4b. And we're going to start on page 9 in your packets, and you'll want to have your calculators out. So we want to find the area of the sector. We're given the central angle and the arc length. So these are going to be two-step problems. And all the ones we saw yesterday, we are only working with either the area of the sector or the arc length. Today, we've got both of them in the question. So because we're given the arc length of 6 pi, that's the one we want to start with. So we're going to have theta over 360 is equal to our arc length over 2 pi r. So we have it that our theta is 60, so 60 over 360 is equal to our arc length of 6 pi, over 2 pi r. Now again, I like to reduce things if possible. 60 over 360, if you divide that, gives you 1/6. The pi's divide out, and 6 over 2 is the same as 3 over 1, so this just becomes 3r. And now that's a lot easier thing to cross multiply. R times 1 is r, 6 times 3 is 18. Well, great, we found the radius, but that's not what we're looking for. We're looking for the area of the sector. So the reason this is a two-stepper is now we've got to do our proportion for area of the sector, which is theta over 360 equals area of the sector over pi r squared. So we're looking for the area of the sector, so we'll have 60 over 360 again. We'll have the area of the sector, and we just found that our radius was 18. Well, we know from before that the left reduces to 1/6. And if we square out the 18, we get 324 pi. We can get cross multiply. We'll have 6 times the area of the sector is equal to 324 pi. And if we divide both sides by 6 by doing opposite operations, we get the area of the sector is equal to 54 pi. And they didn't tell us units on the arc length, but it's an area, so we'll just say, oops, I misspelled there, units squared. So if they talk about both the arc length and the area of the sector in the problem, then that's going to be a two-step problem. Next one, the directions are pretty similar. They want us to find the area of the sector, and they give us the arc length. So because we have the value for the arc length, again, we'll start with our proportion for arc length. Theta over 360 is L over 2 pi times the radius. So our angle was 120 over 360. 8 pi was our arc length over 2 pi r. You don't have to reduce, but I think it makes life easier. 120 over 360, if you punch that in the calculator, gives you 1/3. Over on the right, the pi's divide out, and 8 over 2 is the same as 4 over 1. So this just becomes 4 over r. And then that's a lot easier cross multiplying. You can just do in your head, r will equal 12. Well, now we want to find the area of the sector. So we've got our theta over 360 is equal to the area of the sector over pi r squared. Theta was still 120 from before. Our area of our sector is what we want to find, and we know from the previous part that our radius is just 12. So the left we saw previously reduced to 1/3. And if we square out the 12, this is just 144 pi. Cross multiplying, we get 3 times the area of the sector is equal to 144 pi. And if we divide by 3, our area of the sector will end up as 48 pi. We have units this time, so it's inches squared. So these last two were ones where they talked about both area of the sector and the arc length, and we wanted to find the area of the sector. So the next two over on page 10, we're going to go the reverse. We talk about the area of the sector. They tell us what that is. We want to find the length of the arc. So we want to find the arc length. So these will be two steppers again. Because they gave us a value for the area of the sector, we want to start with our proportion for area of the sector. Theta they told us was 60, so 60 over 360 equals our area of the sector 1.5 pi over pi times the r squared that we don't know. We saw in some other ones, 60 over 360 reduces to 1/6. Our pi's can divide out, so we have 1.5 over r squared on the right. If we cross multiply, we get r squared is equal to 9. And then when we take the square root, we get r equals 3. Well, now we want to find the arc length. So let's use our arc length proportion. So theta over 360 should equal the arc length over 2 pi r, because 2 pi r is the circumference formula. We know theta is 60 still. We're looking for the arc length. And we have on the bottom 2 pi times the radius. Well, the radius was 3, so 2 pi times 3 is going to give us 6 pi. We know again that the left reduces to 1/6. And if we cross multiply, we get 6L equals 6 pi. Divide both sides by 6, and we get L is equal to pi. And they didn't give us units here, but it's an arc length, so it's one-dimensional as opposed to units being squared. Going down to the bottom, find the arc length. They give us the area of the sector, so pretty much same idea. We'll start with the area of the sector one, so theta over 360 is equal to our area of the sector over pi r squared. The area of the sector is the area of a small slice of the circle. Pi r squared is the area for the whole circle. So we've got 72 over 360 equals our area of the sector 5 pi over pi r squared. Again, you don't have to do this. You could just cross multiply right now, but I think it's nice to reduce that fraction on the left and do any reducing you can on the right as well. Makes things a little easier to cross multiply. If you reduce 72 over 360, just by punching it in the calculator, you end up getting that that's 1/5. The pi's divide out, and we're left with 5 over r squared. If we cross multiply, r squared would equal 25. Opposite of squaring something is taking the square root, so we just get r is equal to 5. But that's not what we were looking for. We were looking for the arc length. So let's do our arc length proportion now. Theta over 360 is equal to our arc length over 2 pi r. Oops, 2 pi r, not r squared. Well, the theta was still 72, so 72 over 360. We want to find the arc length. 2 pi times our radius of 5 will give us 10 pi. We know the left from before is going to reduce to 1/5. If we cross multiply, we get 5L equals 10 pi. And if we divide both sides by 5, we get that L is equal to 2 pi. And this time we had units. Arc length is a one-dimensional measurement, so we have feet. So if we move over to page 11, up till this point in your math careers, you have always measured angles in degrees. But if you were to measure the width of, say, your desk, you could do it in inches or you could do it in centimeters. They both get the job done. They both tell you like how far it is across. It's just different units of measure. Well, the same thing is true for angles. There's different units of measure. We've always used degrees up to this point, but there's also a unit of measure called a radian. So the radian measure is always the ratio of the arc length to the radius. So theta represents the central angle, but it has to be in radians. Okay, so your angle in radians is always equal to the arc length over the radius. And it's important that the angle's in radians, otherwise this formula does not work. So the angle in radians is always equal to the arc length over the radius. So down on the bottom, we're just going to show you, well, what's the conversion between radians and degrees? If you work with inches and centimeters, 1 inch is about 2.54 centimeters. That's what the conversion is. So let's maybe see what is the relationship between degrees and radians. So theta over 360 is equal to L over the circumference. So 2 pi r. That's what we've been working with for a while. Now we saw up above that if we are in radians, we can say theta is equal to L over r. So you can replace the L with r theta, and then your circumference is 2 pi r there. Well, notice the r's can divide out, and you're left with theta over 360 equals theta over 2 pi. Well, that means that 360 and 2 pi should be equal to each other. Well, if you divide by 2, that means pi is equal to 180 degrees. So pi in radians is equal to 180 in degrees. So that's your conversion between degrees and radians. So if you have pi radians, that's the same as 180 degrees. So if we go over to page 12, again, if you're working with an angle in radians, your formula is just your angle in radians is equal to the arc length over the radius. Well, they tell us theta, our angle in radians, is pi over 4. So we're going to put pi over 4 on the left. Our arc length is what we want to find, so we'll leave that as r. And then the radius, they tell us, is 12. From there, all we're going to do is cross multiply. 4 times L is 4L. 12 times pi is 12 pi. Divide both sides by 4, and we get L is equal to 3 pi. And our units of our arc length should always be the same as the units of our radius. So again, this is only if your angle were to be in radians. Okay, and it's just a different unit of measure. So we again want to find the arc length, L. We know our angle in radians and we know our radius. So our angle in radians should be equal to the arc length over the radius. So this time we have pi over 2 for the angle in radians. We don't know our arc length, but our radius is 6. If we cross multiply, we get 2L is equal to 6 pi. And if we divide by 2, we get L is equal to 3 pi centimeters. So it's not always going to be 3 pi. Okay, it's just coincidence they were both in this case. A and B's answers are actually completely different answers because one is in inches, one is in centimeters. But they do look similar. Well, now let's see, if we're given an angle in radians, how can we find the area of the sector? Well, normally if we did area of a sector, we did theta over 360 is equal to the area of the sector over pi r squared. But if we're in radians, we need to switch that 360. We said that pi radians was equal to 180 degrees. Well, then what would 360 degrees be? 360 is double 180, so if you double the pi, 360 would just be 2 pi radians. And that's something that's going to come up a lot in Algebra 2. Pi radians is the same as 180 degrees. 2 pi radians is the same as 360 degrees. So we're just going to change this now to theta over 2 pi equals the area of sector over pi r squared. So the top one we would use if our angle is in degrees. The bottom one we would use if our angle is in radians. So now we'll just fill things in. We've got pi over 3 all over 2 pi is equal to our area of a sector. Pi times 9 squared is going to give us 81 pi. So our pi's are going to divide out. And then what we would put in the calculator, this is really a 1/3 on the top. So you would do 1/3 divided by 2. You can do it without a calculator by doing a keep change flip. 1/3 times 1 over 2, if we multiply across, gives us 1/6. So this will be 1/6 is equal to the area of the sector over 81 pi. Cross multiply, we get 6 times the area of the sector equals 81 pi. And if we divide by 6, 81 divided by 6 doesn't come out as an integer, so two ways you can represent it. You could say 27 over 2 pi, or that's the same as 13.5 pi. And we had inches as our unit, so the area of the sector would have to be inches squared. Seven's going to be the same idea. We have area of a sector, which they tell us is 16 pi. So this is our AS. We've got our radius. We want to find the measure of the central angle, but in radians. So normally with area of the sector, when we are in degrees, we did theta over 360 equals the area of the sector over pi r squared. So that's when we're in degrees. But as we just saw in the last one, if we're working with radians, 360 degrees is the same as 2 pi radians, because it's pi for each 180 degrees. So this is what we're going to work with in this problem. And because we want to find the central angle, we're looking for the theta. So we're going to have theta over 2 pi equals our area of our sector, which they told us was 16 pi. And then if our radius is 8, pi times 8 squared will just give us 64 pi. If we reduce the right side, the pi's divide out. If you do 16 over 64 in your calculator, that's going to give you 1/4. And then that makes this pretty manageable to cross multiply. That would be 4 theta equals 2 pi. And if you divide by 4, you could either say that we have 1/2 pi, you could say 0.5 pi, or you'll a lot of times next year see 1/2 pi written as pi over 2, because the pi times 1 is just pi. And then our units is its radians. So radians, 180 degrees is just the same as pi radians. One last one for today on page 14. The arc length of a circle is 15 pi, so that's our L. If the radius is 10, so that's R, find the measure of our central angle in radians. So there's two ways we can do this. We can do this with our proportion that we've been working with. We originally always started with theta over 360 equals the arc length over 2 pi r. But because we're in radians, we would have to switch the 360 to 2 pi, like we've done in the last two questions. Or you could use our shortcut formula with arc length that we saw a second ago. Your radians is equal to the arc length over the radius. And we'll show you, you'll get the same answer for either of them. So we want to find the central angle, so we would have theta over 2 pi. The arc length is 15 pi. And if your radius is 10, 2 times pi times 10 will give us 20 pi. The pi's divide out on the right, so we have theta over 2 pi is equal to 15 over 20. You can divide them both by 5, so you get 3/4. If you cross multiply, we get 4 theta equals 6 pi. And if we divide both sides by 4, 6 over 4 can be divided by 2 each. So we would get 3 pi over 2 radians. Now, if we use the shortcut formula, theta would equal 15 pi, which was our arc length, over 10, which was the radius. And then 15 over 10, you can take a 5 out of each, and that directly gets you to 3 pi over 2 radians. So we do have that shortcut, but only if we're working with arc length. Okay, if unsure, just use our full proportions that we've used on the other ones. So as you're doing your homework tonight, when you see a problem, flip back to your notes, find one from the notes that is very similar, that will help you with the setup, and then go through and solve. Have a great rest of your day.